Hello everybody. Today I am going to tell you about continuity of a function and when a function is said to be continuous. Already I have told you about left hand limit and right hand limit. Clear? So f of x is a function is said to be continuous at x is equal to c if limit x tends to c f of x is equal to f of c, and this is called the limiting value and this is called the functional value. Clear? And the question is that f of c should be well defined or defined. Either in the question it will be defined or it should be defined. That means either f of c, the value of f of c will be given, it is 0 or 1 or 2, or if it is not given, then you should find out that value. And when you will find out, so your value should be defined. That means it should not be plus minus infinity. Clear? And limit x tends to c f of x should exist. And I have told you, when a limit of a function is said to exist, if the left hand limit is equal to right hand limit. That means that is between limit x tends to c plus f of x exists. That means right hand limit exists at x is equal to c, and limit x tends to c minus f of x exists. That means left hand limit exists, and bit 3 left hand limit should be equal to right hand limit f of x should be equal to limit x tends to c minus f of c plus f of x. Left hand limit must be equal to right hand limit, and bit 4 f of x f of c is defined. Clear? And bit 5 limit x tends to c minus f of x is equal to limit x tends to c plus f of x is equal to f of c. If these 5 conditions are satisfied, then the function is said to be continuous at the point x is equal to c. You should write the point where it is continuous. At x is equal to c, it is continuous. It may be discontinuous at other points. So you should mention the particular point. The function f of x is said to be continuous at x is equal to c if these 5 conditions are satisfied. And if any one condition fails, then the function is said to be discontinuous. Clear? That means the right hand limit should exist, left hand limit should exist, and left hand limit is equal to right hand limit. That means the limiting value exists, and the function value should be well defined or defined, and the left hand limit is equal to right hand limit is equal to functional limit. That means this condition. So you should find the left hand limit, then right hand limit, so that you will get the limiting value, and the function value either it will be given or you have to find out. And if all these values are equal, then the function is said to be continuous. Otherwise, it is said to be discontinuous. Clear? So let us take an example. F of x will mod x by x when x is unequal to 0, and 0 when x is equal to 0. You have to test at x is equal to 0. And what is the meaning of this one? The second line. When x is equal to 0, that means when you put x is equal to 0, the value is 0. That means f of 0 is equal to 0. That is called the functional value. Here the functional value is given. Clear? So we should write given f of 0 is equal to 0. Clear? So now only you have to find out the limiting value. That means the unequal to 0 part. Clear? Here x is unequal to 0, you have to find out the limit of this function. Okay. So left hand limit. Limit x tends to 0 minus f of x is equal to limit x tends to 0 minus f of x. That means mod x by x. So how to find out? I have already told you the left hand limit, right hand limit. And if you want to know about left hand limit, right hand limit, so please see the video. Already I have given. So left hand limit and right hand. The video is the last one of limits. Last video of limits. Okay. Here h tends to 0, you should write 0 minus h divided by 0 minus h. So limit x tends to 0, and this is minus h mod. Minus h mod is h because h is always positive number we have taken, and this is minus h, so it will be minus 1. And limit x tends to 0 plus f of x. The limit x tends to 0 plus, this is mod x by x is equal to limit x tends to 0, it is 0 plus h mod divided by 0 plus h. And this is limit x tends to 0, h by h is equal to 1. So this is minus 1, this is plus 1. Therefore, left hand limit is unequal to right hand limit. So limit x tends to 0 f of x does not exist, and hence f is not continuous. At x is equal to 0. Clear? See, this is a theorem on continuous functions. If f and g are continuous functions at x is equal to c, then addition of sum of two continuous functions is also continuous at that particular point. Difference of two continuous functions is also continuous. F plus g is continuous, f minus g is also continuous at that point at x is equal to c. And f into g, product of two continuous functions is also continuous at x is equal to c. And alpha into f, where alpha is a constant. Alpha is any real number. Clear? So alpha into f is also continuous at x is equal to c. 1 by f is continuous provided f should be unequal to 0 at x is equal to c. That means f of c is unequal to 0. Otherwise it will be undefined. 1 by f should be undefined. Okay. So f by g is continuous at x is equal to c. Provided g of c must be unequal to g. C 0. Unequal to 0. So that p by q, already it is known to you. P by q is defined if the condition is that q must be unequal to 0. So g of c, and you are testing at x is equal to c. So g of c must be unequal to 0. Okay. That means overall, if f and g are continuous function, then their sum, difference, product, and quotient is also continuous. Clear? And please remember, there are four functions. That is polynomial function, sine function, cosine function, and exponential function. Are everywhere continuous. Everywhere they are continuous. Clear? There is no point of undefined in case of sine, because the graph of sine is like this, and it is continuous. There is no point of discontinuity. The graph of cos x is also like this, which is also continuous on both sides. And e to the power x is also continuous, 2 to the power x is also continuous. There is no point of undefined. There is no such real number x for which e to the power x or 2 to the power x or 3 to the power x is undefined. Clear? And polynomial, for example, 2x square plus 5. If you put any real number x, and this polynomial is defined, there is no point of undefined. So these four functions, sine function, cosine function, polynomial functions, and exponential functions are everywhere continuous. Clear? So now let us see some examples. So this is another example I am going to give you. F of x of sin x by x plus cos x when x is unequal to 0, and 2 when x is equal to 0, and you have to test at x is equal to 0. Clear? And this is the functional value. When you put x is equal to 0, then you will get its value is 2. So this is the functional value. Okay. So given, see here, f of 0 is equal to 2. And you have to find out the limit of this function, because it is unequal to 0 is given. Clear? So you have to find out the left hand limit and right hand limit of this function. So let us find out. So limit LHN, left hand limit extends to 0 minus f of x. That is limit extends to 0 minus f of x. What is f of x? Sin x by x plus cos x. So you should put a bracket here always. So limit extends to 0 minus, directly I am putting extends to 0. So it will be sin of 0 minus h divided by 0 minus h plus cos of 0 minus h. So is equal to limit extends to 0. This one is sin of minus h by minus h, and sin of minus theta is minus sin theta. Clear? So sin of minus h is minus sin h divided by minus h, and plus cos of minus theta is cos theta. So it will become cos h. So minus minus cancel out, and already it is known to you sin theta by theta, theta tends to 0. Sin theta by theta, limit theta tends to 0, it is 1. So this will become 1. And cos 0 is 1. So 1 plus 1 is equal to 2. So left hand limit is equal to 2. So let us write here. So LHL is equal to 2. Clear? So let us find the right hand limit. I am directly writing here. See here. RHL, this will be plus. This will become plus. And this 2 will become plus. Clear? So this is sin h by h, and this is cos h, and this becomes 1, this becomes 1, so answer is 2. So RHL is also 2. Clear? So that means, therefore, LHL is equal to RHL is equal to 2, which is equal to function will f of 0. So, f is continuous and x is equal to 2. Clear? See, this is another example, and this example is very, very important. And already it is known to you, I have told you in the left hand limit, right hand limit, if the infinity is infinity, and if the minus infinity, it is 0. Clear? And our aim is to make undefined defined. The function which is undefined, and our aim is to make it defined by the help of limit. Clear? So that means 0 by 0, infinity by infinity. These are all indeterminate form. You cannot define this, but you have to define those things. Clear? See here. Here function value is 0. Given f of 0 is equal to 0. Now left hand limit. Limit extends to 0 minus f of x is equal to limit extends to 0 minus. Here f of x is this one. E to the power 1 by x minus 1 by e to the power 1 by x plus 1. Clear? So let us try here. If you write x is equal to, in place of x I am writing 0 minus h. So whether it is defined or undefined, let us say here 0 minus h. So e to the minus 1 by h. And h is equal to 0. 1 by 0 is infinity. So it will become e to the minus infinity. And e to the minus infinity is 0. So it is defined. Clear? So you can put it directly. So limit h tends to 0. It is e to the power 1 by 0 minus h minus 1 by e to the power 1 by 0 minus h plus 1. So this becomes 0 minus 1 by 0 plus 1 is equal to minus 1. So left hand limit is equal to minus 1. So let us see here right hand limit. Limit extends to 0 minus f of x. So it will become limit extends to 0 minus f of x. What is f of x? E to the 1 by x minus 1 by e to the 1 by x plus 1. So sorry, this is right hand limit, means it should be plus. And you should write e to the power 1 by 0 plus h. Clear? So if it extends to 0, then 1 by 0 is infinity, it will become e to the infinity, so that which is infinity. So this is undefined. So in that case, you should divide this term in the numerator and denominator. I have already told this in the left hand limit and right hand limit. So divide e to the 1 by x in the numerator and denominator. It will become 1 minus e to the minus 1 by x divided by 1 plus e to the minus 1 by x. Clear? I am dividing this term, it is 1 by x in the numerator and denominator. So now put the value. Limit x tends to 0 plus 1 minus, x tends to 0, 1 minus e to the power minus 1 by 0 plus h, divided 1 plus e to the power minus 1 by 0 plus h. So now this term becomes 0 because if you put h is equal to 0, so 1 by 0 is infinite, so e to the minus infinite, and e to the minus infinite already I have told you 0. So this one becomes 0, this one becomes 0. That means 1 minus 0 by 1 plus 0. So it is equal to 1. So right hand limit is 1, left hand limit is minus 1. Therefore, LHL is unequal to RHL. So limit x tends to 0, f of x does not exist. And hence, the given function is not continuous, or you may say discontinuous at x is equal to 0. Okay? See here, this is another example. And here, you want to test at x is equal to 1 by 2. And at x is equal to 1 by 2, the function value is 1. Clear? So given f of 1 by 2 is equal to 1. This is the function value. Now you have to find out the left hand limit and right hand limit. See here, left hand limit x tends to half minus. Half minus means it is less than half. Half plus means it is greater than half, and half minus means if you subtract something from half, it will be less than half. So when x is less than half, this one, the function is this one. So limit x tends to half minus, where the function is half minus x. Put a bracket here always. So now limit x tends to 0. In place of x, write half minus h. Half minus h. Clear? So now limit x tends to 0. Open the bracket. Plus or minus or cancel out. So remain h. You will put h is equal to 0. So this will become 0. So RHL, right hand limit. Limit x tends to half plus f of x. Half plus means it is greater than half. So when x is greater than half, so the function is 3 by 2 minus x. So it is limit x tends to half plus 3 by 2 minus x. So it is limit x tends to 0, 3 by 2 minus, in place of x write half plus h. Half plus h, put a bracket here, then another bracket put here. So 3 by 2 minus 1 by 2, it is 1 minus h. So if you put h is equal to, it will become 1. So left hand limit is unequal to right hand limit. You should write, finally you should write left hand limit is unequal to right hand limit. So the limiting value, that means limit x tends to half f of x does not exist. And hence the given function is discontinuous at x is equal to 1 by 2. Clear? See here this question. Here only the function is given and the point is given. So here function value is not given. You have to find out the function value. Clear? So see here, f of 0, function value. Put x is equal to 0. That means 2 into 0 is 0 and 0 modulus is 0. So answer is 0. So here function value is 0. Now take left hand limit. Limit x tends to 0 minus f of x. So is equal to limit x tends to 0 minus, your f of x is 2x minus mod x. So put a bracket here. So limit x tends to 0. So 2 into 0 minus h minus 0 minus h modulus. Clear? So put x is equal to 0. Because this is, or if you write like this, it will be minus 2h. So minus modulus of minus h is h. So it is limit h tends to 0. This is minus 3h, and if you put x is equal to 0, so minus 3 into 0 is 0. So now again right hand limit. Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus, and the function is 2x minus mod x. So limit x tends to 0, 2 into 0 plus h, you should write 0 plus h minus 0 plus h mod, put a bracket. So limit s tends to 0, it is 2h minus h. So 2h minus h is h. So limit s tends to 0, h. And if you put h is equal to 0, it will become 0. So function will be 0, left hand limit 0, right hand limit 0. So you should write LHL is equal to RHL is equal to f of 0. So the function is continuous at x is equal to 0. Clear? See here, this is another type of question. Find the value of k for which the function f is continuous at x is equal to 3. It is given continuous at x is equal to 3 and you want to find out the value of k. And it is known to you, I have already told you, if a function is continuous, then the limiting value is equal to function value. See here, since f is continuous, it is given, na? If it is continuous, at x is equal to 3, the limiting value must be equal to function value. That means limit x tends to 3, f of x must be equal to f of 3. Clear? And limit x tends to 3. What is f of x? It is x square minus 9 by x minus 3 is equal to f of 3 is k. It implies, and you can factorize it also, because 9 is 3 square, so x square minus 3 square, it is x plus 3 into x minus 3. So x minus 3 cancel out from the numerator and denominator. So remain x plus 3 is equal to k. So put x is equal to 3. So 3 plus 3, it is 6. So 6 is equal to k. So the value of k is 6. Clear? See here. Here also you have to find out the value of the constant. But in the previous example there was one constant. Here there are two constants a and b. You have to find out the value of the constants a and b such that this function is continuous at x is equal to 1. Already I have told you, the left hand limit must be equal to right hand limit must be equal to function value for continuity. Okay. And here, see here, f of 1 is equal to 11. When you put x is equal to 1, the value is 11. So this is the function value. And left hand limit x tends to 1 minus f of x. 1 minus means less than 1, because you are subtracting something from 1. So limit x tends to 1 minus. So x is less than 1. So this is the equal function. So 5ax minus 2b. So limit x tends to 0. 5a in place of x write 1 minus h minus 2b. So put x is equal to 0. If you put x is equal to 0, you will get 5a minus 2b. Clear? Then right hand limit x tends to 1 plus f of x. 1 plus means it is greater than 1, because you are adding something with 1 to 1. So limit x tends to 1 plus f of x. What is f of x? If x is greater than 1, the function is 3ax plus b. So it is equal to limit s tends to 0, it is 3a in place of x write 1 plus h plus b. So if you put h is equal to 0, it will become 3a plus b. 3a plus b. Clear? So since f is continuous at x is equal to 1, so left hand limit must be equal to right hand limit is equal to functional value. That means this value 5a minus 2b is equal to 11 and 3a plus b is equal to 11. And if you solve these two equations, so you can get the value of a and b. So you can do these things. Clear? See here, f of x or x mod of x minus 2 at x is equal to 2. So how to do this one? First of all, find f of 2. F of 2 means 2 minus 2 is 0. And left hand limit x tends to 2 minus f of x. So it is called limit x tends to 2 minus, what is f of x? Here x minus 2 mod. So limit x tends to 0, in place of x write 2 minus h, minus 2, mod of this one. So if you open the bracket, minus 2 plus 2 cancel out. So limit x tends to 0, it is minus h. So it will become 0. And then RHL. Limit x tends to 2 plus f of x is a limit x tends to 2 plus, here f of x is mod of x minus 2, it is equal to limit x tends to 0, in place of x write 2 plus h minus 2 and mod of this one. So minus 2 plus 2 cancel out. So limit x tends to 0, it is h, which is equal to 0. If we put h equal to 0, so it is 0. So right hand limit is 0, so left hand limit is 0, and the function value is 0. So that means you should write finally that RHL is equal to LHL is equal to f of 2 is equal to 0. So the function is continuous at x is equal to 2. So any mod function, that means if you have to test this one, in general I am going to tell you x minus a mod at x is equal to a is always continuous at x is equal to a. Is always continuous at x is equal to a. Clear? So I have tested x minus 2 mod at x equal to 2. So it is similar. X minus mod of x minus at x equal to a. It is always continuous. Always continuous. Clear? So this is all about continuity, and in the description I'll give you questions. So if you do those questions, it will be better for you. Because in the next video I will tell you about differentiability. Clear? And I will tell you some relationship between differentiability and continuity. In the exam, the question will be, so test the differentiability and continuity of the function this one. You have to test both differentiability and continuity of a function at a particular point. Okay, so that's why I have told you about continuity. In the next video I will tell you about differentiability, and after that I will tell you how to test both differentiability and continuity of a function. Clear? Thank you.